sun, a giant sphere of intrigue. This churning ball of gas may look like an artist's rendering, but it's the real thing.
Jupiter has the most exotic weather patterns we've ever seen in the solar system.
Jupiter is 84% hydrogen and almost 14% helium, the two lightest and most abundant elements in the universe, rolled into a mammoth mass.
This thing is 11 times the diameter of Earth, and you could take 1,000 Earths and stuff them inside Jupiter comfortably.
Jupiter really is the lord of the solar system. You know, about 70% of the mass in all the planets is in Jupiter. If you're talking about planets, Jupiter is the big boy in the block, and it really does rule the roost.
Jupiter is the largest planet in the solar system, visible to the naked eye. A day is only 9.9 hours long, and it takes 11.86 years to orbit the Sun. A 150-pound person would weigh 350 pounds on Jupiter. There are thunderclouds made of ammonia, sulfur, and water. Exploring Jupiter would be NASA's most daring mission to date. It's a hostile place with temperature extremes from frigid to fiery. Its electromagnetic radiation is intense. It could kill a traveler to the planet in an instant.
We would need heavy lead protection, and that's very difficult to lift off the ground. So we have some difficult engineering challenges to actually bring human beings to the planet Jupiter.
A landing on Jupiter is not going to happen. Jupiter itself is a very gassy planet. It's made of gas, so you would not have a solid surface on which to land and walk around. You would just keep descending through the clouds and then be eventually crushed by the pressure of Jupiter's atmosphere that make a human trip to Jupiter quite a challenge.
But what if we could go there? Dr. Andrew Ingersoll is an authority on the planet. He takes us for a ride.
You need a special kind of balloon because Jupiter's atmosphere is hydrogen. Hydrogen is the lightest gas. A helium balloon would sink. So the only thing that'll float in a cold hydrogen atmosphere is hot hydrogen. And so you need a hot air hydrogen balloon.
For the past 10 years, NASA has been developing ultra-long duration balloons for robotic exploration. And as we all know, heating hydrogen is a tricky thing. But just how this behemoth was born is a puzzle.
The formation of Jupiter is the greatest mystery associated with the planet.
Some believe Jupiter may have been a failed star. Like the Sun, it had the right ingredients, hydrogen and helium, but not enough mass to create the internal pressure and temperature necessary to have nuclear fusion. So it became a planet instead.
The thought is that there was this cloud in the galaxy that had the same composition as the Sun. And it collapsed under its own gravity, and some stuff was left behind, and that stuff became the planets. And the majority of that stuff became Jupiter, and the rest of it, of course, went into the Sun, and then there were a couple of little tiny leftovers like Earth.
Jupiter's spinning gases attracted like elements and over time grew bigger and bigger in the process. Almost like an oyster creating layers around a grain of sand to make a pearl. What gases and solids Jupiter didn't ingest, it spat out into space.
So Jupiter is like your big brother in the schoolyard, protecting you from bullies that might wreak havoc on your existence.
I tend to think of it as more of the cosmic frisbee guy. It's grabbing things out of space, and it's also tossing them back out. It ends up keeping those objects from the inner solar system where Earth and Mars and Venus are.
By cleaning some of the debris up, kicking some of it out, shooting some of it into the sun, where it'd be lost forever, Jupiter cleaned out a path that the other planets could exist in some sort of peace.
So dominant is this frisbee phenomenon, Earth may owe its very existence to Jupiter.
It influences the courses of comets and even some meteors and asteroids, so that over the eons, the fact that Jupiter is there helps dictate what happens in the inner solar system. So really, the presence of Jupiter may be one reason why we have life on Earth and habitability and be able to have the Earth a nice environment instead of getting pummeled by so many comets.
There is no greater proof of Jupiter's power play than what happened during a 7-day period in July of 1994. A comet called Shoemaker-Levy 9 barreled toward Jupiter. Once under Jupiter's influence, there was no going back. A missile was on a crash course with a ball of gas. Jupiter's gravitational pull was so great that it broke the comet into small pieces that came in one at a time. These pieces assaulted the planet at a speed of 37 miles per second.
When you have a missile going at supersonic speeds, you get a shock. You can see sort of clouds of material being jetted up from beneath where it landed.
One of the fireballs generated by the collision with Jupiter's atmosphere flared 1,800 miles into space. Had Earth been in the projectile's sights, the effects of such a smash-up would have been catastrophic, to say the least. Similar to the event that wiped out the dinosaurs.
The energies that were released in those fragments hitting was larger than, on the order of 10 or 20 times more powerful than the entire world arsenal of bombs.
Take Jupiter out of the picture, bring this giant comet into the inner solar system. Where would it have gone? We have no idea. Might have crashed into Earth. If that comet had crashed into Earth, things would be a lot different around here.
The experts believe that comet strikes on Jupiter may be 8,000 times more frequent than those on Earth, thanks to the Frisbee effect.
But it cuts both ways because Jupiter has no value system. When it sees an errant comet, it may attract it and swallow it up, but where it flings it is anyone's guess. And so errant comets can be flung in towards Earth, they can be flung into the sun, and they can be flung out of the solar system.
There's a reason the planet rejects some of the space junk heading its way.
Jupiter, being the biggest object in the solar system, has the most gravity. And so other objects, little fleas that have their own trajectory flying by, are bent from where it would be towards Jupiter, and usually with an acceleration. And that acceleration can cause it sometimes to just be ejected completely.
No earthly Frisbee thrower can match Jupiter's flinging force. It is much faster than any bullet ever known. It rejects things at a rate of 30 miles per second. Jupiter's wonders are hard to fathom. They've captivated man for centuries.
Prehistoric humans realized that it was moving among the stars, and it was one of the planets that they appreciated. And Jupiter was the king of the gods, after all, in Roman mythology.
And there may be a biblical reference to Jupiter.
Ever since I was like 5 years old, I remember people, oh, that was the Star of Bethlehem. And whether or not it really was, obviously we have no way of knowing. But it's not clear whether the star that was talked about is a single star or whether they meant an astronomical alignment of objects in the sky. We don't really know.
It's known as conjunction in scientific terms. According to researchers, Jupiter and Venus did appear as one large star-like object in August 3 BC and would have been visible in the eastern night sky. But it was Galileo, the father of modern astronomy, who made the first recorded sighting of the Jupiter system.
In the early days of 1610, only about 18 months after the telescope was invented, he got his own telescope and he looked at Jupiter.
In 1665, Jupiter's most fascinating feature was discovered. Its giant red eye was actually the eye of an enormous storm, unlike any experienced on Earth. This one has raged for at least 300 years. This weather disturbance is a meteorologist's dream.
Jupiter's Great Red Spot is truly huge. You could take Earth and fillet it out and it wouldn't even really cover the spot.
This storm is the hugest storm in the solar system. Just to give you a feeling about it, it's about 12,000 miles. And the Earth is only 8,000 miles wide.
And the winds blow quite fast around the edge, but it's calm in the center. It's not like a hurricane, which has an eye and very fast, turbulent winds in the center. The red spot is rather calm. If you were in a balloon, it might be a pleasant ride, as long as you avoided the small-scale stuff like the thunderstorms and the turbulent places. Even though you'd be going very fast, it might be quite calm.
Fast as in 350 miles an hour. The fastest wind ever recorded here on Earth was 231 miles an hour. But is it an Earth-like storm?
It's a giant collection of clouds roiling around, lightning going on. So we can only model and imagine what kind of precipitation, but condensation in the form of condensed vapor of various gases.
This famous red spot is a high-pressure system that can take 10 days to complete a rotation.
It's really a backwards hurricane. It's called an anticyclone. That's the name for it. So it goes backwards from the direction of a typical hurricane.
That's not the only curious thing. Hurricanes as we know them need water in order to form. There's no water engine in the red spot. This never-ending weather system is feeding on something else. But what? Jupiter's Great Red Spot is something like a non-stop hurricane. It's a colossal storm, complete with violent wind and lightning. Storm chasers would love to go running after it. Dr. Tim Dowling of the University of Louisville is in the hunt for similar phenomena here on Earth.
The red spot is, think of it as a huge extra lens or egg shape of mass. It's just an enormous thing. It sort of quiets down the fluid, it presses it down into the hotter interior so you don't get thunderstorms. But if you go on the edge of the red spot, especially northwest, you get some of the most horrific thunderstorms you're going to find on the Jupiter.
The spot doesn't have an eye, and it isn't fueled by water. There's no ocean over which it forms. What then keeps it going and going?
I've always likened it, in my own view, as like a mini volcano inside of Jupiter.
Actually, an atmospheric volcano. Dr. Baines believes that warmer gases rise from heat deep within the planet. While trying to escape, they create a vortex.
So for some reason, I believe there's extra energy right there.
But it's just a theory. Science is left without answers to that question and others. Current theories cannot quite explain why the spot is so well formed and why it stays in one place. The plot thickened over the years as scientists learned even more.
It became a deeper mystery because instead of everything just sort of smoothly going around the red spot, we saw this turbulence, and there were smaller scale structures that would come and go every day, and it was chaotic and turbulent, and yet the red spot just existed and sailed on.
Jupiter's storms aren't limited to the Great Red Spot. Cloud decks 3 layers thick hover and cover the planet.
If you were inside the atmosphere of Jupiter, you would hear very loud thunder. In fact, the thunder actually travels 4 times faster on Jupiter than it does on Earth. It's about 3,000 miles an hour. The rain falls twice as fast on Jupiter. The charge separation that pulls the positive charge to the top of the clouds, the negative charge to the bottom of the clouds, is twice as efficient on Jupiter for that reason alone, because the rain is falling so much faster. Towers of cumulus convection that you see on Jupiter are 3 times taller. They go up 30 miles, whereas on Earth they go up 6 or 7 miles.
It would be impossible to survive within the Great Red Spot with its 350-mile-an-hour winds. By comparison, Hurricane Wilma, which had the highest recorded winds of any earthly storm, slammed into the Yucatan Peninsula in 2005 with barely a breath. 175-mile-an-hour blasts. Our weather is simple. Jupiter's is complex.
Now on Jupiter, you just basically have one storm system sort of stacked on another, with lots and lots of room. Basically, these are the storms in their natural state.
These storms move relentlessly within Jupiter's other distinct feature, streams of fierce jets that continually circle the planet. Scientists are only beginning to understand what they are and where they come from.
There's a massive eastward flow of material, and that means material's flowing more than 1.5 football fields per second. That's really moving. You don't want to be in that.
29 other belts and zones of varying widths extend outward from there. They are what give Jupiter its characteristic appearance. They move in alternating directions, some eastward, some westward.
They're much smaller scale, the high latitude jets, than the equatorial one. As far as in comparison to Earth, these are massive, super fast, high speed winds, and yet they're just going back and forth.
The planet's rotation rate has something to do with it. Jupiter generates a lot of energy because it really moves.
So the very nature of the spinning causes Jupiter to not just have one jet stream, but many jet streams going in opposite directions along the planet. And so you can see these zones. So what you have is an exaggerated version of Earth's basic weather pattern.
The spectacular swirls are created in surface clouds where the zones meet. It's believed that the energy ultimately powering this belt phenomenon comes from intense heat deep within. It's not unlike something we see every day.
You boil a pot of water on a stove, it'll start bubbling, and bubbles come up from the bottom and try to get out, trying to circulate that water, that currents around. So it's the same thing inside Jupiter. We have gases and liquids down there that are trying to get the heat out.
There are basic questions, basic pieces of physics to go after, to explain. Massive jets. Shouldn't we be able to explain that?
Earth has just one primary jet stream. It moves eastward, and another major flow that blows westward, the trade winds. Triple that power, and you've got the jet streams of Jupiter.
Totally different from Earth. And yet, I should be careful, not totally different from Earth, just Earth on steroids.
And you ask yourself, wow, if I understood what's going on Jupiter, Earth would be just a piece of cake.
Jupiter's mysteries aren't limited to the planet itself. Some of its most intriguing elements are circling around it.
Jupiter's got several dozen moons that are big enough to be seen. It's probably got a lot more that are too small to be seen with current technology, and no doubt in coming years more will be discovered.
Some of the moons are almost the size of some planets. So really Jupiter is its own little solar system.
Thanks to its incredible gravitational pull, it sucked in asteroids along with other space debris. For the most part, there is order, but there are some erratic moons in orbit around Jupiter. It's managed chaos.
You can imagine a bunch of runners in a track and their lanes that each runner stays in. They won't collide. That's kind of how celestial mechanics.
Each moon holds its own fascination. 4 of Jupiter's prominent moons were discovered by Galileo. He first observed that they revolved around the planet. They are named for Jupiter, the god's lovers.
The first major moon you come to is Io, which is this very active place with lots of volcanoes. It's almost all the time going off.
Shooting out magma 200 miles into space. Io is a wonder, pockmarked with over 100 volcanoes, some the size of California, which seem to turn themselves on and off. Ganymede is the largest moon in our solar system, 5 times the size of Earth's moon. Callisto is the most heavily cratered. It has clearly taken a beating in its lifetime. Then there's Europa, the ice queen to Jupiter's king. No one knows its makeup for sure.
It looks like a cracked egg. It really looks like the whole thing had liquid water on it at some time. It froze and it cracked. And we believe that these patterns are due to tidal forces that crack it.
As alien as Europa seems, it is smooth and glassy in some spots, hilly in others. In fact, it is remarkably similar to one of Earth's frozen wonderlands.
There is a lake in Antarctica called Lake Vostok that scientists think is an analogy to what we see in Europa. Antarctica has a huge thick ice crust, and underneath there is this liquid lake, and we think that this may be very similar to the water ice underneath the surface that we see on Europa.
You go down through that crust, you go through the ice enough, you'll get liquid water, and we are very convinced that there's liquid water down there. It's the only place that we know of besides the Earth which has liquid water in large bodies that have been there, we believe, for more than 1 million or 2 million years.
And where there's water, could there be life? Jupiter's moon Europa is bursting with secrets. It may even have warm thermal vents deep below its frozen crust.
In fact, an immense ocean, bigger than the Pacific Ocean, worth of liquid water down there that's just sitting there for things to happen to.
The presence of water means one thing. We may not be alone.
I want to go ice fishing on Europa. Cut a hole, put a submersible, look around, see if anything swims up to the camera lens and licks the camera. That's what I want to do.
One scientist is planning just such a fishing trip. At this outdoor lab near Austin, Texas, hopes are hanging on a little robot.
This is designed for exploration in unknown territory, completely unknown territory, and the search for biological life.
It's a Deep Phreatic Thermal Explorer, or DEPTH-X for short. Its proving ground right now is a local quarry. And there are big plans for its future.
If everything went according to plan, you would launch around 2016. It would be at Europa by 2018, and by 2019, for certain, we know whether there's life off Earth. That's the game.
DEPTH-X is the brainchild of engineer Bill Stone. He and a team of scientists have staked their reputations on it. They've spent 6 years developing the concept and building the prototype. It's part of an ambitious project that would see it carried into space, sent through 6 miles of ice, and into Europa's ocean.
To divide it down into all the various vehicles, you have a parent vehicle which takes you to orbit around the moon Europa. There will be a lander. It'll land on the ice. Then there's a second stage of the lander which melts its way through 3 to 5 kilometers of ice cap, and then at that point you kick out the third stage. We need a fast-moving device that would be sort of torpedo-shaped, most likely nuclear-propelled, and that would drive for thousands of kilometers around the central ocean of Europa.
Is that really feasible? NASA thinks so. The space agency is on board with money and its blessing, an investment in the search for life. If life exists on Jupiter's moon Europa, could it walk, talk, or fly?
It would be little viruses or, maybe at best bacteria. We would expect only to see primitive life forms, but they might be similar to things that we see on the Earth. We just don't know.
Scientists are encouraged by the discovery of strange and hardy life forms found in the most inhospitable places on Earth. Tube worms, for example, survive and thrive in total darkness. Extreme pressure isn't a problem. The creatures were discovered in 1977, several miles below the surface of the Galapagos Rift. They exist in water near superheated thermal vents. It's believed that these very conditions, darkness, high pressure, and hydrothermal vents, are present on Europa.
You could have hydrothermal vents kicking up warmth and nutrients down near the core of Europa, and that organisms would have fed off of that material just like they might have in the early Earth.
And while tube worms might not be lurking beneath Europa's icy shell, something else could be.
Its microbial life is the bulk of life on Earth. We expect that branches of that type of life will exist on Europa, just simply because water is the key feature.
Finding it consumes scientist Bill Stone. His DEPTH-X may answer a question that excites seekers of knowledge.
Can we have the robot behavior look for signs of life and then try to collect a sample based on what it's sensing?
Stone's baby is in its infancy. At the same time, it is futuristic and advanced. It's a high-tech toy like no other that might show our world what another is all about. our first contact with extraterrestrial life may be on Jupiter's moon, Europa. The DepthX robot, or more accurately, Hydrobot, is being designed to ultimately think, move, and explore without help from man.
And that is all to be done by the robot itself. We're not going to be guiding it to do that. That's going to be a big step forward in what we would call robot science autonomy.
It's a real-life HAL, the star of a new space odyssey.
Where it's literally hit a button and let it dive below the surface, and we won't see it again until it tells us what's down there.
DepthX will be able to extract and analyze samples on its own as it navigates the ocean.
This little tube you see down here will pull in water samples and store them in 1-liter bags. We have 5 of them on board. But before it does that, it actually powers through a series of micro pumps over here on the left and brings it into an onboard microscope. And that microscope will take images of what's in the water down to about 5 microns. So we can see most of the typical types of microbial life from 5 to 200 microns on screen. The robot will use that to discriminate to determine if there's life and then grab a sample.
DepthX and its systems must be made smaller to work in space. And it still must pass trials under ice flows.
We are testing this in Antarctica to make sure it all works totally under ice.
The question of life on Europa is probably the big unknown, because that would change our whole view of the universe, basically. I mean, if this little moon sitting out there in this hostile environment of Jupiter can have life form on it, that means that probably tells us that life is almost everywhere.
The science is there. I mean, I think searching for life is one of the most compelling things that we can do as not only as scientists, but as a race, as human beings.
It's a giant leap, and not just for mankind.
No, for robot kind.
Of all Jupiter's imposing features, none is more impressive than the one you cannot see. It's bigger by far than the Great Red Spot, more dynamic than the bands of jet streams, and as lethal as any killer known to man.
You have one of the most powerful radiation environments in the solar system, aside from the sun.
The magnetic field of Jupiter is the largest entity, I believe, in the solar system.
It is a bubble 450 million miles long, buzzing with electrically charged particles. It's Jupiter's magnetosphere.
The sun's sitting here putting out the solar wind, and the solar wind is charged particles of protons and electrons.
These particles flow along at 1 million miles an hour.
And Jupiter basically captures these protons, electrons, all these charged particles like electrical currents, and it has it then in space circling around Jupiter.
No word in the English language accurately conveys the enormity of this phenomenon.
The magnetosphere of Jupiter is the biggest object in the solar system. It's a lot bigger than the sun.
Comparisons are the best measure of this mega mighty wonder.
If it were visible in the night sky, it would be many, many times bigger than the moon. It's enormous, even though it's 5 times as far away from Earth as the sun is, it still would look immense in the night sky.
If visible, it would take a familiar form, a windsock. There's a rounded section facing away from the planet in one direction, with a tail flowing out the other. this windsock reaches the outer orbit of Saturn. Power plant Jupiter generates up to 10 million amps of electrical current.
The biggest planet in the solar system can conduct electricity all the way through it and around it.
This conductivity creates a phenomenon we can see when the excited charged particles escape.
Jupiter has auroras because when those particles leak in and crash into the upper atmosphere, it glows, and just as Earth has auroras.
These ghostly auroras are 1,000 times more powerful than Earth's northern and southern lights. They measure up to 1,200 miles across. If you could stand under them, they'd fill the entire sky, moving at lightning speed, 10,000 miles an hour. Jupiter's magnetic field is a monster, and it roars. In fact, it's speaking to us right now. Jupiter, the giant of the solar system, has something to say if you're listening.
We can hear what we call lion roars because it has this roaring sound. We can hear whistler modes. We can hear hiss and whistles that are going pew, pew, pew. And these are all indications of dynamics, things that are happening in the magnetosphere now.
If you find yourself driving on a dark desert highway, your AM radio might just tune in to the strange sounds of Jupiter's magnetosphere. The bursts are as short as a few seconds and as long as a couple of minutes. They come and go every hour or two.
Most of it sounds like static, but every once in a while you pick up something that sounds like a rising tone or a falling tone.
Some listeners have described audio spasms that sound like woodpeckers or waves crashing on the beach. The noise is disturbing. But just why the planet was talking remained a mystery until Voyager 2 passed through the outer magnetosphere in 1979.
Nobody really understood for a long time how those signals were generated. So that was one of the things that was on my mind when I got interested in Jupiter. What in the world was going on with these radio emissions?
It is one of the few secrets finally surrendered by Jupiter.
And that answered some questions, but it raised new ones. And I think that's the way it should be. If you don't have questions, it gets kind of boring and dull. So I think that the fact that the planets don't give up their secrets easily, or the universe doesn't, that's part of the game. It's what makes it interesting.
Jupiter keeps astounding and confounding scientists. One surprise came in 1979 when it was discovered that Jupiter has a ring. It's nothing on the order of Saturn's. Still, it's another feature that fascinates.
All of the giant planets have rings, probably left over from when the planets formed and the moons coagulated out of the gas that was there, and then it could be a failed moon. So Jupiter's ring comes from material being knocked off of one of the interior moons. So it's dust that's collected from material that's coming in from outside moons.
The ring is slowly growing as new material flows into it. And there's a whole other side to the planet that remains a mystery. Why do these storm spots keep forming? There's the dark spot, for example. Glimpses of it were first spied in 1997. It appeared to be a huge, ominous cloud, twice the size of Earth, hovering above Jupiter's North Pole. There's a host of other spots, too.
There are other sort of smaller cousins that have come and gone. There were 3 ovals about half or a third the size of the red spot. And they sort of occupied the same latitude band in the southern hemisphere. And they'd been around since the 1930s. And amateur astronomers saw them form. And they were around till the late 90s. And 2 of them merged with each other. And then the remaining 2 merged, and now there's 1.
And it keeps transforming.
It turned red about 6 months ago, and now we're calling it the little red spot because it turned color. Now, why did it turn color is a big question. So there's chemistry going on, or some type of extra dynamics that's going on that just kicked in, and we need to start studying that.
Jupiter is a hostile and restless planet. Its giant gaseous body and violent storms make it one of the most alien environments.